going to show you how you could do it in Desmos. If you did the work, that's great. If you didn't and are writing the answer now, you can put solve in Desmos or did in Desmos. So for the first one, I can put this in Desmos. And put what word here. And looking at this, I can count on the graph. This is going down 1, 2, 3. This is going to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I simplify that, I know it's a negative slope going down 1/3. So that slope would be negative 1/3. Again, if you did that in Desmos, you could say did in Desmos, that would be your work. Number 2 could be done in Desmos if you type in the equation y equals 3. I can see that this is a horizontal line. I don't have any drive, but I have a run, so that would be some 0 over something, which would make it just 0. You didn't need work for this. If you knew horizontal lines have 0 slopes, you would just put equal 0. And then for the third one, the graph is a little off. So if you found something other than this number, that was also fine. But this should have crossed at every 2/1, even though it's a little off. So the slope should have been. Question on any of those? Hold on to the chart by make sure your name is on it. I don't need the other one back. I would say start keeping these so that you can have something to refer back to for practice for the SLM. It is slowly approaching. I don't have dates yet. I'm assuming sometime end of April, beginning of May. Okay. You have a couple things next. One should be a big packet of stuff. That is everything that will be covered on the SLM. Some of that you have gone through, some of it you still have to get through. But to start practicing, I mean, you guys have kind of been practicing through all of the short bites, but to start really practicing through that, each week you're going to have a section or a couple sections that will be due from that. It'll be informative, but not go in grpah because there's going to be a lot of them. You can use each other, use your notes, use Desmos, use me. I'm just going to be checking for how many did you do out of how many problems were there each week. So starting with the next time I see you next week when I see you on the 13th, you guys will be doing all of SOL A1. So that's the first page and a little bit on the back. So all of that will be due on the 13th. And we'll go through how you could have done it in Desmos, the answers, things like that, that way you have basically a study guide at the end when you go to study for that. Right. If you use your course calendar and want to write that on your course calendar, I would do that. And then I would write for each week when something else is due, so I know the next time after that would be so yeah, the 20th would be the next time, so that would be the next set of whatever, and then most likely the 26th after that. Also on your course calendar, take note of your quiz and test dates. The 15th and sorry, I'm looking on the small board. next week, and the week after that are your coding tests. We're going to be moving much faster than we have been to get through the rest of this stuff. After, not this unit, after the next unit, we'll be no longer doing quizzes and tests until after the SOL. So that's going to move even faster, but we'll get to that here. Also take note of your Delta maps. There are 2 due this week, and then a bunch due next week. Questions on any of those? A lot of information is good. This unit we are starting inequalities. Some of it may be familiar to you, some of it will be new to you, but you should have the unit in front of you. Okay. So there are 2 rules when graphing inequalities. We're going to use an open circle for less than or greater than, strictly less than or strictly greater than signs. And then a closed circle for less than or equal to or greater than. So if we were given something like these problems where at the end we have some answers, they want us to graph it. For number 1, would this be open or closed? Open. At 3, so at 3 with an open circle, would this go to the left or to the right? To the left. Less than, so everything below that. If you're not sure, pick a number somewhere on your number line, and you could say, is this number less than 3? If it is, that would be the side that gets the arrow. If it's not, that would not be the side. 3. Would 3 be open or closed? Closed. At 7. Would the arrow go to the right or to the left? Right. Most of the time, the way the arrow is pointing is the way you draw yours, but not all of the time. We'll talk about that. Questions on how to graph this? Okay. Now this is the opposite. Now we have graphs and we have to write what the inequality is. So for number 5, we know it starts at -2. It is an open circle, so that has to be your strictly less than or strictly greater than. Which one would it be? Less than. So everything below -2. So less than is pointing to the left. Left. Okay. For number 6, we see that it starts at 4. It is closed, so greater than or equal to, less than or equal to, and it would be greater than or equal to. Okay. Questions on how to graph or write so far? So we are actually going to be solving, and then at the end we have to graph it. So there's one major rule for solving inequalities. You must flip this inequality symbol when you multiply or divide by a negative number. I'm going to give you an example of this. You can write this off to the side. If I had like 4x is greater than, negative 4x is greater than 4. If I were to solve this, I'd have to divide both sides by -4. And because I'm dividing by a negative, the sign is going to change direction. Always, no matter what. However, if this is positive 4x is greater than -4, and I divide both sides by a positive 4, the sign does not change. So what you're dividing by has to be negative in order for a sign to change. So if you're trying to get x by itself, this number has to be negative in order for it to be right. Multiplying is basically the same, but it would have to be like some division problem. I'm just making this up for you. If you had some division problem where you had to multiply both sides by -6, that would change the sign. But if the 3 was the one that was negative, it would not change the sign. Yes. If they're both negative, regardless, you're multiplying or dividing by a negative, so the sign is negative. This will become a positive, but the sign will still change. Okay, we have time to do one.
I thought it was only like when you multiply, like, I know it had to be both numbers have to be, like, you know what I mean, like, if you're, since, aren't you multiplying by a positive though?
So here.
Yeah.
Yeah, so that's why the sign would change. The nice thing about solving inequalities is it's the exact same as solving equations. You just have to think about the sign. So how do I solve this? Back to both sides. And then divide by 3. Divide by 3. Is the sign going to change? No. So then you have a blank number line. You can put whatever numbers you want in there. I like to start in the middle and then branch out. You don't have to do that. You just need to fill it up. Would this be open or closed? Open, going to the left or to the right? Left. And we have solved the inequality. Questions on that? Start number 10. How would we solve that? -2. So x over 6 is greater than -3. Multiplied by 6, does the sign change? No. Okay. Again, fill up your graph. I'm going to make this. Open or close? To the right or to the left? When we come back, we will talk about did we have any questions on these two? On the next page, or the back of this page. Now we're doing the same thing, but now we're using interval notation. So when we use interval notation, we have to keep in mind these things. We're either going to be using parentheses or brackets. Sometimes we use a mixture of. We'll talk about when that is. Parentheses are for things that are not included. So like if you would use an open circle, you would be using parentheses. Brackets are for things that are included, or when you would use a closed circle. So if you would go to graph and it's a closed circle, you're going to be using brackets. However, if something keeps going on to positive or negative infinity, you're going to use parentheses. So I'm going to show what that looks like after we solve it. this, we could either distribute the 4 or divide both sides by 4, since this is divisible. Which would we rather? Distribute, okay? So we have 4x plus 12 is greater than negative 24. And then to solve this, subtract 12. So 4x is greater than negative 36. Divide by 4. Would the sign change? No. X is greater than negative 9. So this is going to be open or closed? Open at negative 9. Going to the right or to the left? To the right. Everything greater than negative 9. So how we would write the interval notation is look at where it starts. This starts at negative 9. This is an open circle, so it has to be a parenthesis. And you write from where it starts to where it ends. So starts at negative 9. Where does it end?
Infinity.
Oh, infinity. It keeps going all the way to infinity, and infinities always have parentheses. So these two things are saying the same thing. This is inequality notation or set builder notation, and this is interval notation. Questions on that? Let's try number 2. Go ahead and distribute that. So x minus 3x minus 6 is greater than 4. Combine our like terms. Get rid of 6 by doing what? Adding. Oh, this isn't 4. This is 2. Minus. When we divide, is the sign going to change? Yes. So x is now less than negative 5. Would that be open or closed? Open. To the left or to the right? To the left. Now when we look at where does this start, this keeps going, so where would that start? Negative 5, that's where it ends? Negative infinity. So parentheses, negative infinity, and then it ends at negative 5, and it's open, so also parentheses. Questions so far? Because you're reading left to right. So if I'm reading left to right, does it start at negative 5? Alright, let's try 3 and then I'll let you guys choose some. Alright, we'll do 3 and 4 and then I'll let you guys choose some. Okay, how would we start solving 3? Distribute. So we have 7x minus 2x plus 8 is less than or equal to negative 2. Combine our like terms. Get rid of 8 by subtracting. When we divide both sides by 5, is the sign going to change? No. So when we graph this, is this going to be open or closed? Open. Closed. Closed. Going to the left or to the right? Left. Right. Similar to number 2, where would this one start? Negative infinity. And where would this end? Negative 2, but this time because it's closed, we're going to use a square bracket. anytime it goes to positive or negative infinity, that's always going to be a parenthesis. We will have some examples when we do our next lesson where you may have two square brackets instead, or a mixture of. Alright, number 4, go ahead and distribute. We have negative 8x plus 8 minus x is less than or equal to negative 28. Combine your like terms. Get rid of 8 by subtracting. And when we divide both sides, is the sign going to change? Yes. So x is now greater than or equal to positive 4. With these problems, because you're switching back and forth between strictly less than, strictly greater than or equal to, less than or equal to, make sure you don't lose the sign, the symbol. If you start with an equal to, make sure it carries all the way down. Sometimes you forget a line because it looked like a negative, and then you end up changing the whole problem. So be careful there. Will this be open or closed? Closed. Going to the left or to the right? Right. So this will start at 4. It's closed, so square bracket at 4. And it ends at infinity. Question 6.
Why does it start with a square bracket again?
Because it's starting at 4 and 4 is closed. So it depends on wherever it starts, and if that point is a point and it's closed, then it's square bracket.
Oh.
If it was open, it would be a parenthesis. As well. Say that one more time. So here. Yes. So anytime you have infinity or negative infinity, always parentheses. No matter what. Look at numbers 5 through 10. Find any of those you want to see. Go over how questions are.
8 and 7.
8 and 7. Max. 6 and 10. Okay, let's do those 4. And then if we have other questions, we'll go back and do those. More of the same, but now we have things on both sides. Just like how we would solve equations with variables on both sides. Same thing here. So for number 6, you can pick and choose what you want to move first. What would we want to move first? 2. Okay, so subtract 2x on both sides. At the same time, you can subtract 20. So if you do something like this where the x is now on the right, I'm going to show you how to kind of fix this, change it. You don't have to do this afterwards, but you can if you want. If we divide, is the sign going to change? No. But this is backwards than how we've been writing it. So if you can read it like this and graph it correctly, you don't have to change it. But if you would like to see it where x is in front, you're going to take this whole thing and you're going to flip it. So whichever direction this is pointing to or away from the x, do the same thing. So right now this is pointing away from the x. So point it away from the x. So these mean the same thing. This one you would just read backwards. X is greater than or equal to negative 7, which is the same as this. So again, not a necessary step, but if it helps you see it, you may want to do that. Would this be open or closed? Closed. Going to the left or to the right? To the right. This would be a case where if you not going to point to the left. It's still going to point to the right. So be careful if you leave it like this. Make sure it's drawn the right way. Right? This is starting at -7, so would it be parenthesis or bracket?
Bracket.
Square bracket at -7, and it ends at infinity, parenthesis or bracket. Questions on that problem? Right. Number 7. Distribute first, but remember that this is an invisible 1 that you're distributing, not the 3. Then you should be able to combine like terms, the 3 and the 7. And then what do we want to move first? Sure. So if we move 6x by adding, we can get rid of 10 by subtracting. So we have 4x is less than or equal to 24. And then divide both sides by 4. Go ahead and graph that on your number line. Should be a closed circle going to the left. How would we start that interval notation? Parentheses, negative infinity. Where does it end? 6. And that would be parentheses or bracket. Yes.
So whatever say it's like a 6 sum, whatever's not infinity is the bracket.
Depending on if the point is closed or not. The number is the parentheses or bracket, yes.
Okay.
For solving multi-step inequalities only. When we get to our next lesson, it'll be different. Yes and no. This is saying every number less than 6 is a solution. So these are all your different solutions, this arrow is. This is saying your x values are from -8 to 6. So they're basically saying the same thing, but they're a little different.
So you get point on because you mark x is
Like if you put x here. Right. Yes, because this interval notation does not have x in it. Okay, let's do number 8. Alright, distribute combine like terms. Be careful, these would not cancel, just become a negative. What do we want to move first? The 2. Okay. So if we subtract 2x, then we'd have to add 6 to the other side. So -8x is less than 24. When we divide both sides, is the sign going to change? Yes. Yes. So x is now greater than -3. Go ahead and graph that. That should be open circle to the right. How would we write that interval notation? Parentheses, -3. Infinity, parentheses. Questions on that? Okay, let's do number 10 and then we're going to switch gears. distribute on both sides. Be careful with your negatives. Combine like terms on both sides. And what do we want to move first? Okay. So we can add 4x and add 3. So we get negative x is greater than 9. Divide both sides by what value? Negative 1. Is the sign going to change? No.
Yeah.
Yes, because we're dividing by a negative. And then go ahead and graph that. How would we write that interval notation?
Which negative?
Parentheses, negative infinity.
And
So if I were to ask you, give me a solution that would work for this, it would be any number less than negative 9. A decimal, a fraction, a whole number, it doesn't matter. As long as you could pick something less than negative 9, that would work. Questions on how we solve multi-step inequalities? How do we feel about solving multi-step inequalities? Good, okay, need more practice, not okay, I don't understand what we're doing. I haven't done that in a while, of battle my heart, I need to do that more. Okay, if you would like to take a second and stretch, you can, otherwise we're going to move on. Go ahead and fill this out. I think these are the last word problems we'll do for the rest of the year, except in SOL practice. So as you're writing, I'll just read. These are the words you'll see the most when dealing with inequalities: at least, at most, no more than, no less than, and less than. At least is greater than or equal to. So if I said I need at least 50% of you to do your Delta math for you guys to get a gumball, more could do it, but I need 50% of you at least to do it. At most is less than or equal to. So if I have at most $100, or if I can spend at most $100, I can't spend more than what I have. No more than and no less than are opposites of what they say. So no more than is less than. I can spend no more than $10 buying snacks. Or I have more than 5 students. I have more than that. No less than is opposite. Trying to give you different examples for each one, but my brain's not working this one. That would be similar to a at least or more than scenario, and then less than, of course, is just less than. Keep in mind the signs that go with these. In this case, less than is not your subtractant, unless you see it twice. Then it is your subtractant. Right? There are 5 problems here, but we're not going to do all 5. We may set up some of them. But just like our regular word problems, we're going to read through it, find important information, define a variable, write the inequality, and solve it. So let's start with number 1. Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 at the end of the summer. He withdraws $25 per week for food, clothing, and movie tickets. How many weeks can Keith withdraw money from his account? What's important there?
Keith has $500.
Okay, he has $500 in his account. At least. What else?
$200.
$200.
$25 per week.
What about the 25? Withdrawals. That's important. And then we're looking for
How many weeks can Keith withdraw?
okay. Just like we were doing with our system, the question is going to help you with the variable, how many weeks, so we can call that W for number of weeks. You could put some of the operations into the problem. If you want to have at least, that's going to be which symbol?
Greater
Less
than
than or equal to.
Greater than or equal to. You can have at least this, so he wants this amount, but if it's more, that would be great. So greater than or equal to. If he's withdrawing money, what operation is that? Subtraction. Okay, and then there's just one thing. Okay. So whenever you have your inequality word, it'll be right next to the number that it's going to be greater than, less than, whatever. So greater than or equal to 200. He wants to have 200, but if he has more than that, that's great. But he doesn't want to have less than that. How would we put the rest of this together?
500 minus 25 W.
500 minus 25W. Since the per week, anytime you see that word, that's going to be where your variable goes. Okay, so we have our equation, our inequality. Now we can solve it. Subtract our 500. And divide everything by negative 25. What happens when we divide here? The sign changes. So W is now less than or equal to, calculate that, tell me what the number is. 12.
12.
Was it 12 exactly?
Yeah.
Okay.
Because 300 is 3 100s and 25 goes into 100 4 times, so just multiply that by 3.
I was not doing the math in my head, but thank you. So then, if he withdraws money for 12 weeks or less, he will have at least $200. So if you wanted to write that as a sentence, it would be something like that. But if he were to go over that 12 weeks, he would not have at least $200. Checking your work is the same as regular equations. You could put this back in. But you're still seeing, does it make itself true? So if I were to put 12 in, the number you get would be either equal to 200 or a little smaller than. But if it goes over 200, then it would not be true. Questions on that one?
If you ever get a negative answer, should you just assume that you've made a mistake?
Yes, unless it's, so if you're solving problems in general, you can get negative answers, but if you're doing a word problem, no, you should not get a negative answer. So then I would double check your work, put it back in, see does it work, and then try and find a mistake.
How much should check in the
So if I were to put 12 back in, I go 500 minus 25 times 12. And we happen to get 200, which was equal to this number. But if this wasn't equal to, or if it was just greater than, that would not be true. Or if it was just less than, that would not be true. But in this case, 200 equals 200. Okay. Let's try number 2. Taxi charges a flat rate of $1.75 plus an additional 65 cents per mile. If Erica has at most $10 to spend on the cab ride, how far could she travel? What's important there? $10. Flat rate of $1.75.
Plus an additional 65 cents.
Okay, and we're looking for how far could she travel? So this is going to be in miles. How far she could travel, the distance going in miles. So we can call that M for number of miles. From when we did work from the very first time, flat rate is a one-time fee. You get charged that no matter how far they actually go. It actually says the word plus, so we're going to be adding the at most, which inequality symbol would be
Less than or equal to.
So I know that at the end this is going to be less than or equal to 10. How would I set up the rest of that?
175 plus
175 plus 0.65 n. And let's solve that. And then tell me what you get at the end.
12.69230769.
One more time.
12.69230769.
I got 8.2.
8.25 for this part, yes. And then I'm gonna just leave that there. If we're looking for number of miles, probably just do 2 decimal places. Also be thinking, can your answer be a decimal? So like the last one, number of weeks could be a decimal, but we really want a whole number.
I think the average amount of children in a household is 3.5 or whatever.
Yeah. Miles can be decimals, so we can leave it as that. So if she rides or travels for 12.70 miles, she's going to spend more than her $10. And if we were to put that back in, you will see that. So you have yes. Yes. And yes. I will let you guys choose between the last 3. Which of those do we want to see? We're not going to do both of these so that you guys have some practice on as well. For number 5, the temperature inside increased 6 degrees Fahrenheit this morning. The temperature is now less than 46 degrees Fahrenheit. What was the inside temperature this morning? What's important there? Less than 46. Increase 6. And what are we looking for? So less than, we're going to use less than. Increase would be which operation? Plus. We need a variable for the temperature. We can call it T. I'm going to put it as capital T.
I would do it as D for degrees. Because the T is like addition.
less than 46 would be less than 46. How would we write the rest of this?
It's x plus 6 is less than 46.
Plus
Sorry,
six.
t.
And then get rid of 6 by subtraction. So, not that this really answers the question because it's not very specific, but we just know that T was less than 40 degrees inside this one.
Do we actually have to solve it? Like when you take points off, we didn't do that even though the equation was literally in the.
So, show your work, yes. Okay. You guys have about 30 minutes left. You can either keep working in this, or you have 2 Delta Maths that are due on Friday, one on the word problems, one on the solving. You could get both of them done before you leave. You could also be working on the SOL packet that is due next week for SOL A1. So you have a bunch of different things to be working on. Oh, really quickly. Just so you see how this works in Desmos so that you can be checking your answers. I'm just going to put number 10 in. Okay, when you have your inequality, solve it algebraically, but then you can put it in Desmos to double check it. Wherever the line is, that will tell you basically the same thing when you were graphing. It'll show you whether it's less than or greater than. The dash and solid line we'll talk about next in a couple classes, but dash would mean it's open or less than, strictly less than, strictly greater than. Alright, so use Desmos to check yourself, work together. Let me know if you have any questions or need my help.